Performance Pipe's fusion videos should be used in conjunction with Performance Pipe's recommended fusion procedures published in PP 750. These procedures are in alignment with ASTM F2620 standard practice for heat fusion joining of polyethylene pipe and fittings, and can be used with all pipe and fittings manufactured by Performance Pipe, Chevron Phillips Chemical, Driscoe Pipe, Piping Products, and Plexo Pipe, with the exception of Driscoe Pipe's 7000 and 8000 series piping products. Saddle fusion involves the heat fusion of Performance Pipe fittings, including service saddles, tapping tees, and branch saddles to the sidewall of a main pipe. The following equipment is required for saddle fusion: a saddle fusion machine with appropriate clamps for the main pipe and saddle fitting. When saddle fusing to a pressurized main, the saddle fusion machine must have a gauge or mechanism that indicates the force applied when the saddle base is pressed against the heating tool or the main. A piece of 50 to 60 grit utility cloth. Timing equipment such as a stopwatch or watch with a sweep second hand is needed when fusing to 2-inch IPS and smaller mains. And finally, a heating tool with surfaces contoured and correctly sized for the main pipe and the fitting base. Serrated heating tool faces are preferred. Follow the machine manufacturer's instructions for proper use and operation of the equipment. Performance Pipe recommends a heating tool surface temperature of the following. Lower heating tool temperature can lead to a blowout during saddle fusion to a pressurized main. All points on both heating tool surfaces must be within the prescribed minimum and maximum temperatures where the heating tool surfaces will contact the main or the fitting. The heating tool surfaces must be clean. Use clean, dry, non-synthetic cotton cloths or paper towels to clean heating tool faces. Install the saddle application tool on the main pipe according to the tool manufacturer's instructions. The saddle application tool should be centered at the location where the fitting will be fused. The application tool must fit on the main pipe without interference or restriction from other piping components, obstructions, fusion beads, or the like. The area of the main pipe where the saddle fusion machine and the fitting will be located must be clean, dry, and free of deleterious nicks, gouges, or cuts. If alcohol wipes are used, use only before abrading the surface, never after abrading the surface. The surface should be wiped dry with a clean, dry, non-synthetic cotton cloth or paper towel after using the alcohol wipe. Abrade the fusion surface of the fitting base and the mating fusion surface of the main pipe with a 50 to 60 grit utility cloth. On the main surface, abrade a surface area that is the size of the fitting base plus around 1/2 inch per side all around. It is necessary to completely remove a thin layer of material from both surfaces. After abrading, brush the residue away with a clean, dry, lint-free cotton cloth or paper towel. Do not touch abraded or cleaned surfaces with your hands. Regular replacement of the utility cloth is necessary. A worn or dirty utility cloth may not abrade the surface properly. Poor surface preparation can cause poor fusion quality. The tapping T-caps may need tightening before placing them into the unit. Install and lightly clamp the fitting in the saddle application tool. Move the fitting base against the main pipe and apply moderate force to seat the fitting against the main pipe and in the fitting holder. It may be necessary to wiggle the fitting a little to be sure it is completely sealed and squarely aligned against the main. While maintaining force, secure the fitting in the saddle application tool. There are 3 forces associated with saddle fusion: bead-up force, heat soak force, and fusion force. The 3 forces are printed on the fitting label. The bead-up force in pounds is the first number on the fitting label. During bead-up, force is applied to form an initial melt pattern on the main and the fitting base. Bead up ends when the melt is visible at the top center of the main on both sides of the heating tool. Bead up force should not be applied for more than about 1/3 of the total heating time. The heat soak force is the second number on the fitting label. This is always 0. During heat soak force, the fitting, heating tool, and main are held together but without applying force. The fusion force is the third number on the fitting label. The fusion force is applied to the fitting against the main immediately after the heating tool is removed. The fusion force must be maintained for the duration of the first cooling time period. In a quick, continuous action, place the heating tool on the pipe centered beneath the fitting base and immediately lower the fitting against the heater face. Apply bead-up force and begin timing as needed. Refer to ASTM Standard F2620 or Performance Pipe Bulletin 750 for maximum heating times. When saddle fusing to a pressurized main, do not exceed the maximum heating time, as blowout may occur. Also, when fusing to a pressurized main, do not remove the heating tool to inspect the melt pattern on a main pipe, as this can cause blowout. At the first visual indication of main pipe melt at the curved center of the heating tool face on the main, that is, the crown of the main, reduce the bead-up force to heat soak force. The heat soak force is always 0. Continue timing until the indicated total heating time expires or a melt bead of 1/16 inch is visible around the fitting base. Quickly separate the heating tool from the fitting and the main pipe and remove the heating tool. Saddle fusion machines from different manufacturers may require particular techniques for separating the heating tool from the fitting and the main pipe without disturbing the melt. Follow the saddle fusion machine's manufacturer's instructions. Quickly inspect the melt on the main pipe and the fitting base. The surfaces should be completely melted. Regardless of the main pipe or fitting melt condition, quickly join the fitting to the pipe and apply and maintain fusion force for the first cooling time period. Always join the fitting to a pressurized main pipe after heating. If the fitting is not joined to the main pipe immediately after heating, the pressurized main pipe may rupture. The cooling time is 2 successive cooling time periods. Fusion force must be maintained for the duration of the first cooling time period. Never reduce fusion force during the first cooling time period. Reducing fusion force during the first cooling time period may result in blowout during hot tapping. If the saddle machine force gauge reading rises on its own during the first cooling time period, allow it to do so. Allow the joint to cool under pressure for the minimum cooling time found in Performance Pipe Bulletin 750 or ASTM F2620. At the end of the first cooling time period, the application tool may be removed. After removing the application tool, the joint must be allowed to cool undisturbed for an additional 30 minutes. After the second cooling time period ends, the service or branch line may be connected or pressure leak tests or tapping may be conducted. Do not try to shorten cooling time by applying water, wet cloths, or the like. If the melt on the main pipe or the fitting base was unacceptable, the saddle fusion should not be placed in service. To prevent use, the fitting should be cut off near the fitting base. Do not attempt to remove the saddle fitting base. Leave it in place to reinforce the main pipe. Move to a new location on the main pipe and install a new saddle fitting. Follow the complete saddle fusion procedure when installing the new saddle fitting in the new location. For larger fittings greater than 3-inch IPS outlet and mains larger than 6-inch IPS, a flexible heat shield may be used to preheat the pipe during bead up. This prevents the fitting from melting before the pipe. Place the iron on the main and the heat shield between the heating tool and fitting base. Then apply bead up force. When a melt bead first becomes visible on the main all around the heating tool, release bead up force, raise the fitting slightly, remove the heat shield, move the fitting against the heating tool face and reapply the bead up force and start the heat time. When a melt bead is first visible all around the fitting base, usually 3 to 5 seconds, reduce bead up force to heat soak force. Maintain heat soak force until a 1/16 inch melt bead is present around the fitting base. At the end of the total heat time, remove the iron and proceed to fusion force, and continue as usual with the saddle fusion procedure. Visually check the fusion beads around the entire fitting base at the main pipe. The fusion beads should be uniformly sized all around the fitting base and should have a characteristic 3-bead shape. The first bead is the fitting base melt bead. The second or outermost bead is produced by the edge of the heating tool face on the main. The third or center bead is the main pipe melt bead. The fitting and pipe melt beads should be about 1/8 inch size all around the fitting base. The heating tool edge base should be visible all around the fitting base. Refer to ASTM F2620 or Performance Pipe Bulletin 750 for a troubleshooting guide with pictures of acceptable and unacceptable fusions.